Hello. Today we're going to learn how to solve a linear system by substitution. Last class, you guys learned that you could get the solution to a system by graphing your two equations. So I would put those in slope-intercept form, and you graphed them, and you see where they intersect. And they intersect at that point right there. Unfortunately, that point doesn't actually hit an actual grid line, so I'm going to have a really hard time coming up with the solution. So what I'm going to do is I'm going to show you how to do using substitution. So the very first step is that you are going to choose one of these equations up here, and you need to get one of the variables alone. It doesn't matter if it's x or y, doesn't matter at all, but we want to choose the one. Now it's often easiest to isolate the variable with a coefficient of 1 if there's one available. And what do you know? There is. So what we're going to do is we're going to get that y right there alone. And so to do that, you guys know that you're going to add 6x to both sides. Okay? So that second equation right there, I just made it y equals 7 plus 6x. Now, that 7 plus 6x is the expression that y is equal to. And since when two lines intersect, the place where they intersect, the x and the y are the same, what we're going to do is we're going to take this expression right here, and we're going to replace the y value in the other equation with that expression, because y is 7 plus 6x. So you take the other equation, and I'm going to replace, instead of writing 3y, I'm going to write 7 plus 6x plus 2x equals 3. So this is basically the same equation as this, except that I've replaced the y with what the y value equals in the other equation. Hence the reason it's called substitution. So that's what we just did in step 2. So step 3, you will then have an equation with all the same variables. What do you know? We have x's here. Okay, so we're going to solve the equation for that variable, which we know how to do. We distribute and we get 21 plus 18x plus 2x equals 3. Combine your like terms, you get 21 plus 20x equals 3. Isolate your variable, subtract 21, we get 20x equals negative 18. Then we're going to divide by 20, and you get x is equal to negative 18 over 20. And that reduces to negative 9/10. So we have that the value of x is negative 9/10. Now, of course, an ordered pair is our solution. So we have x. We now need to find y. So this is very simple. We are simply going to replace negative 9/10 wherever we see x in either one of these equations. So we have these two equations, but then we moved this one around and we got y alone. Any of these are going to give us the same y value. So we're going to replace negative 9/10 with the x. Okay, so we're going to go ahead and get rid of some of this work here so that you can see what I'm going to do next. And I know that x is negative 9/10. So let's go ahead and replace. We had here that y is equal to 7 plus 6x, right? And we know that x is negative 9/10. So we are going to replace, and we're on step 4 right now, we're going to replace the x with negative 9/10. So I'm going to get 7 plus 6 times negative 9 over 10. Now, of course, we are not going to get freaked out by that little fraction. We're going to make that 6 over 1. Before we multiply, let's go ahead and cross cancel. So I'm going to divide by 2 and get 3 here, and we're going to get 5 here, which gives me y equals 7 minus 27 over 5. And then, of course, we need to find a common denominator. So y is equal to, our common denominator is 5, so that's going to give us 35 over 5 minus 27 over 5. And so we get that y is equal to 8 over 5, which is 1 3/5. Okay, so we got here, let's sum this up just a little bit. We now found that we have x and we have y, so we are actually now on step number 5. So we got that x was negative 9/10 and we got that y was 1 3/5. that's an ordered pair. So we're going to go ahead and write our answer as an ordered pair. So x, negative 9/10, and y, 1 3/5. And that is your solution to the system. Okay, and so now step number 6 is we got to check our solution. So we're going to go ahead and check our solution. So let's get rid of some of this stuff here. Got all this writing going on. Let's get rid of it. Okay, so there's my solution right there. And I'm going to take that and I'm going to plug it in. So if I'm going to put it in for 3y plus 2x equals 3, I'm going to do 3 times, instead of doing 1 3/5, let's go ahead and change that back to 8/5 plus 2 times negative 9/10, and we are going to hope that that equals 3. If it doesn't, we did something wrong somewhere. So let's get rid of our solution because we know what that is. So we've got some room. All right, so we'll make that 3 over 1. I can't do any cross canceling, so that's just 24 over 5. Plus, let's make that 2 over 1. I can do some cross canceling here though. That can become a 1. That can become a 5. 1 times negative 9 is negative 9. 1 times 5 is 5. And we want it to equal to 3. And 24/5 plus negative 9 is the same as 24 minus 9. And last time I checked, 24 minus 9 was 15. So I get 15 over 5 is equal to 3. And you guys know that 15 divided by 5 is actually 3. So you get 3 is equal to 3. Okay, so now we need to check the other one. So I'm going to have negative 6 times our x value, and our x value was negative 9/10. So I'm going to have negative 6 times negative 9/10 plus the y value, which we said was 1 3/5, which is 8/5. And we're going to say, does that equal to 7? So make that 6 over 1. I can do some cross canceling here. I'm going to divide both of these numbers by 2. So this is going to become negative 3, and that's going to become 5. Negative 3 times negative 9 is 27, so I get 27 over 5 plus 8/5 equals 7. And last time I checked, 27 plus 8 was 35, so 35 over 5 equals 7. And you're going to get here that 7 is equal to 7. So you did it correctly. Go ahead and move on to the next page and try the next problem. Okay, if you didn't pause the video and try it, you might want to try that first. So our first step in substitution is we need to pick one of these variables and get it alone. It is always easiest to pick the variable that has a coefficient of 1. It does not have a number in front of it. So we're going to go for that y right there. And so to get that y alone, I'm going to subtract 3x from both sides. And so you're going to get that y is equal to 5 minus 3x. So now that is your expression for y. Y is equal to 5 minus 3x. So you are going to replace the y in the other equation with 5 minus 3x. So I'm going to get 6x minus 3, and your expression has to go in parentheses. 5 minus 3x, close your parentheses, equals 30. And so now distribute. So I'm going to get 6x minus 15 plus 9x equals 30. Combine your like terms. 6x and 9x is 15x minus 15 equals 30. Add 15 to both sides, and you are going to get 15x equals 45. And then divide both sides by 15, and you are going to get that x is equal to 3. So then, now that you have x, you need to go and you need to find y. The easiest place to put the x is to go ahead and put it right here. You can put it here, you can put it here, and solve for y that way, but this one, y is already alone, so why don't we just put the 3 right there. So what we're going to get is y is equal to 5 minus 3 times 3, which gives us y equals 5 minus 9, and 5 minus 9 is negative 4. So your ordered pair is 3, negative 4. And that is the solution to the system. And then you're going to take that and you're going to plug it into your x and y for both equations to see if that works. I'm going to let you do that on your own. Go ahead and pause the video and try number 2 on your own. Okay, number 2. We want to first step, get a variable alone. And if you look at both of these, d is already by itself. So what you are going to do is simply replace, I can replace this d with negative 4c plus 8, or I can replace this d with c plus 7. Either way, what you're going to get are these two expressions are equal to each other. So I'm going to have negative 4c plus 8 equals c plus 7. Then variables on both sides, I like to add 4c. You could also subtract c if you wanted. So I'm going to get 8 equals 5c plus 7. And then I'm going to subtract 8 from both sides. Nope, I'm sorry. I'm going to subtract 7 from both sides. And I'm going to get 1 equals 5c. Then you divide by 5, and you get that c is equal to 1/5. And so then now what I need to do is find out what d is, and the easiest place to put that is right here, because all I have to do is 1/5 plus 7, which is easy. I could put it here, but you get the same answer. It's just going to take you a little longer. So I'm going to say d is equal to 1/5 plus 7, and I get d is equal to 7 1/5. So there you go. Our ordered pair. If you've got different variables, go ahead and just put them in alphabetical order, unless you know that they mean something, which we'll get to later. So I'm going to get 1/5 and 7, and 1/5 is our solution. And all I got to do now is check it. All right, moving right along. For number 3 is ridiculously easy. It says x is equal to y. So all I need to do is, in the top equation right here, I can replace the x with the y, or I can replace the y with the x, because both of those variables are alone. So basically, since x is equal to y, this y could be x, or this y could be, or this x could be y. So if let's say I replace the y with x, so I'm going to get 2x equals x plus 3. So I basically replaced something in the top with something from the bottom. Subtract x from both sides, and you get here x is equal to 3. And since x equals y, you already know that it's going to be 3, 3, because x and y are equal. Done. Okay, just a reminder that you should be checking these, but I'm not showing the checks because you can do the checks on your own. All right, so this next one, again, substitution, get a variable alone. There is already a 1 alone, so I don't do any moving around. I'm going to take this expression, negative 2y plus 6, and I'm going to put it right there where the x is. So I'm substituting the x with negative 2y plus 6. So it's going to look like this. I'm going to get 6y plus 3, replacing the x with negative 2y plus 6, because the above equation says that x equals negative 2y plus 6. The whole thing equals 18. So we are going to distribute, and you're going to get 6y minus 6y plus 18 equals 18. Uh-oh. 6y minus 6y is 0. So I get that 18 is equal to 18. Oh my, what does that mean? Well, when we solve linear equations, that means that y is all real numbers. However, the solution to the system is not all real numbers. The solution to the system is just infinite. The reason we don't say that the solution to the system is all real numbers is because the system has ordered pairs, and ordered pairs are all the points on the line. So if we said all real numbers, that's kind of like saying, well, it's every ordered pair in existence, but it's not. It's every ordered pair that falls on the line. These guys are the same line, basically. If you put them both in slope-intercept form, you'd get the same equation. So that's that. For this one, there is no check. Okay, if you continue on to the next page, you will find that number 5 is no solution. If you go ahead, get y alone, or you don't always have to get y alone, but in this case you should get y alone and solve, you'll find that you get something that's no solution. And then the word problem, if you have questions on that, you can go ahead and ask me in class. Hope this was helpful.